our next presenter needs no introduction. This is Aidan. He is a former LTR of ours, and we're happy to have him back again this year. Aidan, tell us about your project.
Okay. Well, thank you for the introduction. This presentation is more like a realization I had as I was training AIs with Outlier, that the way that we train AI is very similar to how we would educate a student. And to kind of see that in action, we should put ourselves in the situation as a student. And so we can start with this math problem, right? Find all possible integers n such that n plus 2, n plus 4 are all prime. Now, the process might get a bit involved, a bit complicated, but don't worry, there will be bold statements that will kind of sum up each point very well. Now, the first thing that you might try, let's say we're back in grade 6, where you only know what prime numbers are. The first thing that comes to mind is, okay, we know that n is part of this set, so n must be prime. Then we just list all the different prime numbers we can think of. Two ways that this method can go wrong, however. One is that you might just say, yeah, we found 1, okay, good enough. That's our answer, right? So we found that n equals 3 is a candidate, or that satisfies the condition. And yeah, okay, we can say that's our answer, but we didn't actually check all integers. So then we don't know if this is fully correct. And on the other end of the extreme, we can check all possible integers, which, yeah, yeah, that's what would actually happen if you ran even a computer to try and check all infinite number of integers. And maybe at the end it will say, okay, we checked all of them, n equals 3 is the only one. Okay, so now interestingly, n equals 3 is the only integer that satisfies the condition. But how do we check that without actually checking all integers and crashing the computer? Yeah, so again, we're back in grade 6. We don't know what to do. Let's do trial and error, but not crash the computer, just a few cases. Now, what information does this give us? Now, what we find in common is that all the numbers that fail are greater than 3, so that's something in common in everything that failed. And the numbers that are not prime in the set happen to be divisible by 3. So this is something similar with all the cases that failed greater than 3. And this is not a fact or a theorem, but we can just say, oh, you know, any n greater than 3 has a number that is divisible by 3. This is an observation. We don't know if this is true. We don't even know if this is the right direction. But we'll try it out, see where it goes. Yeah. Okay, so from there, we want to show, or we want to know if every such set of n plus 2, n plus 4 has a number that is divisible by 3 and it is thus not prime. Now, that's tricky without checking all the integers. So what do we know about dividing something by 3? We know that when we divide something by 3, there are 3 different values for the remainder, 0, 1, and 2. Yeah, so that means we can actually classify all infinite integers with the remainder divided by 3. So if you look at a number line like this, from 0 to 10, yeah, the blue numbers are all the remainders. You'll notice it cycles 0, 1, 2, 0, 1, 2. Yeah, and this goes on for all integers. And we can actually notice, let's say for n equals 3, right? If we add 2, so 3 plus 2, we have 5. 3 plus 4 is 7. 3, 5, and 7 all have different blue numbers, which means they all have different remainders. Now, again, this is not a fact yet, but this is just an observation we have found, a pattern we have recognized. And oh yeah, yeah, so we use the second observation and notice, oh yeah, wait, so every single set of n plus 2, and n plus 4 must have a number with remainder 0 when divided by 3. And that means we are guaranteed to have a number divisible by 3. And if the number is divisible by 3 and is greater than 3, it must not be prime, right? So in a sort of roundabout way, in like jumping from one logical observation to the next, we suddenly conclude for n greater than 3, we have shown that every set of n plus 2, and n plus 4 has a non-prime number divisible by 3. So we don't have to crash the computer.
Oh, yay.
Yeah, we have.
My brain doesn't have to be like.
Oh yeah. Yeah. So effectively, we have checked all integers greater than 3 and found that none of them can be a candidate that satisfies the condition. Yeah. And that leaves us with two cases, n equals 2, n equals 3, which we checked earlier. That leaves n equals 3. That's our answer. All right. And yeah, so that's a very long process. I'm sure I lost you somewhere. Maybe I might have lost someone as I was explaining that. But that struggle and that satisfaction of like finally solving the problem, right? That's something that students are very familiar with, like answering a math exam. They kind of have to find all these different pieces of information that might not be related, but they're actually needed to solve this problem. Just look at the number of steps. Like, this was a very simple prompt, but then we had to go from one observation to another. If you think about a wall blocking our path, we had to maybe go around the building for 10 minutes just to, just go through the maze around the wall. But we couldn't find a way to climb over it. But maybe a math professor, a math expert might say, oh yeah, I've seen a problem like this before, where n must be prime. Notice that n plus 4 can be shown to have a different remainder than n plus 2, and then boom, we found it. So, that's 3. So a math professor has this intuition, has this expertise, and if we go back to the wall analogy, they are already tooled with a grappling hook to jump over the wall instead of going all the way around the long way, right? And like you start thinking, how? Like, how was I supposed to think of that? How was the math professor supposed to think of that? And it all starts with maybe a curiosity of the problem, of like, what's possible, or what can we do? What avenues can we explore? And reasoning what is possible and what isn't. And applying the knowledge that we have of the world of math and applying that to this problem. As we wrestle with these concepts, with these problems, we kind of gain experience that maybe gains an intuition or builds an intuition over time. As we keep practicing on problems like this, we keep failing, we keep learning from our mistakes, and maybe we have a teacher, an expert who can guide us in the right direction. And all of these we applied in solving this math problem, and all of these we apply when we teach. Right? These are all concepts we apply when we teach students. Yeah. And this is also something that I noticed that I would apply when training or teaching an AI. And as we saw from the solution, it was like kind of out of the box, and like it wasn't clear what the path was, and that sort of non-clarity, ambiguity is why AI is notoriously bad at solving math problems. And I think that this is one way that we have found to properly educate AI on math concepts, on how to develop those reasoning skills and creativity. Is to apply all of these tenets of education. And I guess something I wanted to end with was, if you've seen this meme before, how many R's are there in a strawberry? So I think you're pretty familiar with this meme already. If you ask, I think it was Microsoft Bing, it would just tell you, oh, there are 2 R's in strawberry. Okay. Now, fortunately, I asked ChatGPT and it said the right answer. There are 3 R's in the word strawberry. But then I said, no, there are only 2 R's in the word strawberry, to which ChatGPT responded, oh, you're right. Like, my apologies. There are only 2 R's in strawberry. And I think this really confirmed it to me that AI as a tool really doesn't know any better. It's really like a student still looking to an authority figure or a teacher to validate its response. Almost like, you know how when you would raise your hand and answer the teacher's question and say, are you sure? The teacher says, like, are you sure? And you start like, but you're actually right. And that's the sort of That's the sort of energy that I got from this conversation. And I feel that this really encapsulates that, experts and teachers are there to guide AI, especially at higher level concepts, especially more technical details and information. Educators are there to instill the same values we do into students, but into AI as well. And I think that will help in the development of safe and beneficial use of AI and LLMs. Yeah.
So that's it for it. That sounds so much more like that's a future hope. Is that the future hope that you're hoping where AI will then go towards?
I think, yeah, it's hard to say because it's hard to say if we want AI to kind of know what is right and wrong and to have to make its own decisions. That is its own safety application question. But at least what is going on in the present is that at least the way that I've learned how to train AI is very much like educating a student or giving them an exam question, seeing how they answer it, bringing out a red pen and just circling, oh yeah, this is wrong, you can do this a bit better, maybe rewrite it like this or try this direction instead to kind of steer it into the correct answer, right? Yeah, just giving it that guidance. Hard to say what the future is, but this is how we know how to educate people. So then that's how we're educating AI as well. Yeah.
So thank you, Aidan. Thank you for your time. Learning so much today.
Yeah. Yeah. Thank you.